We're going to turn now to looking at a dynamic model. It'll be a two-period model in which the consumer will make a consumption and a savings decision. And so they'll essentially be choosing how much to consume today versus how much to consume in the second period. So we're bringing time explicitly into the analysis. So a wise person once said, time is God's way of making sure everything doesn't happen all at once. But I think Groucho Marx said it best when he said, time flies like an arrow, fruit flies like a banana. In our first model of the labor market, we had one period, and we just imagined that the economy repeated itself every period. Our second model, which was about long-run economic growth, brought time into the picture, but it was really only as a means for accumulating capital and ultimately converging to the steady state. Now what we're going to do is we're going to distinguish between two periods, now and in the future. And we're going to introduce an intertemporal price, meaning a price across time, which is the real interest rate. The real interest rate is going to be the key relative price in this model, and it's going to be the price of goods today relative to goods in the future. So there's going to be a large number, capital N, of consumers, but as before, each consumer is going to be small and is going to behave competitively. Right now, we're going to assume that income is exogenous. So households are not going to be making a decision about how much to work at this point. So households just get income of Y today and YF in the future. And then consumers then are going to optimally choose three objects. They're going to choose current consumption, savings, and future consumption. So the notation is going to be that current consumption is C, savings is S, and then future consumption is C with an F on it. So anything with an F subscript means future. Savings are going to earn a gross real interest rate of 1 plus R. So if you save S today, then tomorrow you're going to receive 1 plus R times S. And R has to be positive. So 1 plus R is going to be bigger than 1. And you want to think about the interest rate in this context as just telling you something about how much consumers are compensated for postponing consuming today. Now we're going to also have consumers pay a lump sum tax. Now we're going to use the notation T for the tax today and TF for the tax tomorrow. So today's disposable income is just going to be Y minus T. That's the endowment minus taxes. And in the future, it's going to be YF minus TF. Now the household faces two different budget constraints. You have a budget constraint that pertains to today, and you have a budget constraint that pertains in the future. So today, the consumer receives Y units of income, so that's in units of goods today. And out of that, they consume, they save, and they pay taxes. Then in the future, they receive YF, units of goods. They also, if they've saved some amount S, then they also get 1 plus R times S in savings, the return on the savings. And out of this total income, they buy consumption goods and they pay taxes. So the left-hand side is just total expenditures, the right-hand side is just total income. Consumers' utility now is going to depend on current consumption and future consumption. Notice leisure is not in there because the income is just taken to be exogenous. And so the household is going to, or the consumer is going to maximize this utility function subject to this budget constraint today and this budget constraint in the future. So households are competitive agents. and they're going to take the real interest rate and exogenous income and taxes as given.